Hey everyone, welcome to day number 5 of the advent of cyber on TryHackMe. Let's not waste any time, let's just go onto the computer and see what today's task is all about. Alright, so we are here on TryHackMe and the title for today's room is IDOR, Santa's Little IDOR, and IDOR stands for Insecure Direct Object Reference, and we are going to learn about this type of vulnerability while helping pentest the TryPresentMe website. Awesome. So the way we are going to divide this video today is going to be like this. There are 3 main parts, right? So first we are going to start with the storyline, then we are going to set up our lab environment, and while that is loading, we're going to go through all of the theory that we need for the practical challenges, and then we are going to dive into those in no time. So yeah, let's just get started with the storyline, shall we? So it looks like the elves of Wareville are on high alert since McSkitty went missing. Recently, the support team has been receiving many calls from parents who can't activate vouchers on the TryPresentMe website. They also mentioned they are receiving many targeted phishing emails containing information that is not public. The support team is wary and has enlisted the help of the TBFC staff. And when looking into this peculiar case, they discovered a suspicious name account called Sir Carrot Bane, which has many vouchers assigned to it. For now, they have deleted the account and retrieved the vouchers, but something is going on. Can you help the TBFC staff investigate the TryPresentMe website and fix the vulnerabilities? Let's try. I mean, that's the least we can do, right? So we have some learning objectives here as well. So here's what we are going to do today. We are going to understand the concept of authentication and authorization, and both of these concepts are very, very important in security. Then we are going to learn how to spot potential opportunities for insecure direct object references, the IDORs. We're going to exploit IDOR to perform horizontal privilege escalation, and we are going to learn how to turn these IDORs into SDORs. So basically the same, but secure direct object reference. So the way I see it is that first we are going to learn some theoretical concepts that are going to be very important for us to understand the impact that a vulnerability like this can have. Then we are going to spot how you can actually spot for opportunities to exploit the IDOR. And then we are going to do it. We are going to go through some exploitation and also learn how to fix it. Perfect. Now, with all of that out of the way, that was the storyline for today. That sounds exciting. So for now, what we are going to do is we are going to connect to our machine and set up our lab environment. And today we only need 2 different things, right? We need our attack box and our VM. So the VM is where the TryPresentMe website is going to be hosted and where we will be able to access it. All right, so it's very, very easy to set up your lab environment with TryHackMe. So all you need to do is click 2 buttons right here. So let me start with the target machine, which is the easiest. So you basically just click on that big green button and it's already loading. Usually it takes like a minute or so. And then you start the attack box, this big white button here on the right side of your screen. So if you click on that, you will see that it opens this right side panel, which is not ideal. Why is that? Well, I'm in the way, basically. So you wouldn't be able to see a lot in there. So what we are going to do is on the bottom part of your screen, you have this little icon here in the middle that says view in full screen. So just click on that and then go back to the main page and click on the minus sign. And then you will basically exit the split view. So then you have full visibility on your tasks, on the theory, on the things that we are going to read through. And then if you want to go into the practical side of things, we go into the lab, which is still loading. It takes a couple minutes. And here on top, you will see that the machine, in just 5 seconds, we will have the IP address, which is pretty cool. Now, if I just click on that little thing on top of me, you will see that we get all the information that we need for our lab. So basically, now we have our attack machine that is still loading with this IP address right here. And then we have our target machine where the TryPresentMe website is being hosted with this specific IP address, which I'm just going to copy right off the bat. And we have around 2 hours to solve the challenge, which will be more than enough. So yeah, let me minimize all of that. And if we keep scrolling down, we can just click on check for this specific task because we don't need to provide any answers. It's just that target machine and attack box are ready to go. Perfect. So let's just click on check. And apparently that was a good thing. We got a nice sound there. Okay, cool. So now I'm going to open our task number 2. You can see here on the top left. Whoops. Sorry about that. Let me click on that again. And okay, so now we are going through some of the theory to understand what is it that IDOR really means, like what type of vulnerability is this? How can we spot opportunities to exploit it? And then we are going to do the practical stuff. So yeah, the reason you have this title here right off the bat is because this vulnerability is very intuitive. It's very easy to understand. For example, if you ever see a website like this, and trust me, I've seen websites like this in the wild, where you have just normal website, okay. Then you have this web page where you can basically track a package. So if you order something, then there's these pages where you can just submit an ID and you can track your package, see if it is still in transit, how many days are still, is it still going to get before you get your package, and so on. But for that, you need to provide a package ID. So there's this parameter here at the end, package ID, and you need to provide a number. Now, when I look at this, I'm like, okay, my package ID is 1001. But what happens if I provide like 1002 or 1003? Like, am I going to get access to data that doesn't really belong to me? Is the application doing any checks in order to only give me access to information that I should have access to? That raises a lot of bells, right? But this actually happens a lot. But in order for us to understand why this is happening on the back end, it's really, really useful to look at this table first. So take a look at this. You have a lot of IDs here on the left. So for package ID, this parameter, you have these IDs. And what is happening on the back end is a query that is very simple, like this one here. So you have a query that is supposed to select the person details, the address, the status from the delivery from this table called packages, where the package ID is a certain value. So you provide this value, right? The 1001, that's your package. So you get your own personal data. Of course, you have access to that. It's your own information. If your name is Alice Smith, right? And you get your address and the status, if it's delivered or if you're still waiting, and so on and so on. But if you provide one of these values here, so 1002, 3, 4, and 5, will you be able to access Bob Johnson's data and all of his personal information? I mean, this raises a lot of concerns when it comes to privacy and even security, because then all of this personal identifiable information is getting leaked pretty much, which is not ideal. So it's really obvious, because if you're using an ID that is basically a sequential number that you can basically predict, like ID number 1, or if it is a username specifically like user number 1, user number 2, then you can basically tamper with that and try to get access to stuff that doesn't really belong to you, which is not very ideal. Now, there are a couple ways that some applications might try to hide this identifier, right? So again, as we spoke, if you have something that is very simple like user 1 or just number 1, 2, 3, or 4, it can be very easy to just replace that with a different set of characters or a different string that is sequential and you get access to other stuff. But what if you get a random sequence of characters like the one we can see here? This might make it harder to guess, as it says here, but if the server still is not checking for permissions, it's just as insecure. Because if you can figure it out, what's the logic behind this random set of characters, then you can still navigate it and try to get access to stuff, as you will see in just a couple minutes. So for that, it's very important that we understand these two concepts: authentication and authorization. Authentication is that thing where you're basically trying to prove if you are who you say you are. And you can do that in a lot of different ways, right? As it says here, this is basically the process which you verify who you are, and you can do it with a username and a password. So I'm David, this is my username, this is my password. Please give me access to all of my data, all of my previous orders, and all of the features that I can use, right? But then there is also authorization, which is the process by which the web application verifies your permissions. So if I'm a normal user, I should probably not have access to a admin portal or any of the other users' data, right? And for that, you need authorization to happen every time you make a request on the applications, not just when you log in. Does that make any sense? I hope it does make sense, because now we are going to cover the last part of the theory that we need for this particular task, which is privilege escalation, but two types of privilege escalation. The first one is the vertical, and both of these are very easy to understand. Again, vertical privilege escalation, I've already gave you an example that matches this. Basically, if you're a normal user and all of a sudden you perform an IDOR attack and you get additional permissions, you basically escalated your permissions to a level that is above what it used to be, right? But if you're talking about horizontal privilege escalation, now this is a different thing. This is where you're basically using the same features you already had access to, but now you're getting access to data that doesn't really belong to you, or you shouldn't even have access to it. For example, if you order something from a website and you're just trying to check your previous orders, it should just show you the things that you've ordered in the past. You shouldn't really have access to orders that were made by other users in the past and access to their credit card information and their payment information and their address and stuff like that. So that would be a typical case of horizontal privilege escalation as well. And this one is the most common. As you can see here, it also says here, IDOR is usually a form of horizontal privilege escalation, not exclusively horizontal privilege escalation. It is also used for vertical privilege escalation, but usually, and it's more common to see an IDOR being exploited in a while as an horizontal privilege escalation method. So yeah, really, really cool. Now, I think it's time to do some practical stuff, right? That was fun. At least we got the theory that we need in order to target the tasks for today. So yeah, I already know that we have our lab ready to go. Yes, there it is. So the first thing that I'm going to do here is just come here on the right side. If I move my face out of the way, we have this toolbar here on the right. So feel free to use this to spin up your applications. And I'm just going to spin up the Firefox browser, put my head back in place, and go back to the main page where we can basically have some sort of understanding of what is up and what is it that we need to do right now, right? All right, so it seems like we have some credentials to access the TryHackMe website, and the username is Niels. Okay, Niels sounds very, very Danish. The reason why I say this is because I'm based in Denmark, and yeah, it's quite fun to see this in here. We have this password and the website. So let's just connect to the website. I hope this copy and pasting is working. So if I come back here and paste it on my browser, the copy and paste does work, which is nice. If you have any problems with copy and pasting stuff onto the attack box, it might be your browser acting up, or I don't know. You have this thing here on the left side of things, and you can use this clipboard here to copy and paste stuff into the attack box, which is pretty neat. But right now, I think we're good to go. So I'm going to log in onto this TryHackMe website by using the Niels account that is going to be our user for today. And I'm going to copy this password and just trying to log in. I don't want to save that password. I think we're good. And okay, I think we can see the same exact thing that TryHackMe is showing us on the main page, right? Yes, exactly. So basically you have the main account information, which is our email, our ID number, our address, our children, and we can basically buy gifts for our kids. We can redeem vouchers. Apparently, Niels has 6 vouchers and has already used 5, which is cool. So what is it that we now need to do? Let's start by using the developer tools of our browser to better understand what is happening in the background. Right-click on the page and click Inspect, then click on the Network tab as below. So we will use the developer tools, Network tab. There won't be anything in there because we need to refresh the page in order to get any of the requests that you can see here. And then let's take a closer look at the View Account Info request and click on it, and you will see the following. And I can already see something here that is not very secure. There's a user ID equals 10. Now, what will happen if we change that number to something else? Let's see. So let's go back to the app, and basically we right click, we click on Inspect, and we go into the Network tab like TryHackMe showed us. And now we basically refresh the page and we get this request right here on the bottom that says View Account Info. Oh yes. And now if we go into this right side and click on the Response tab, oh yeah, we can see a lot of information about Niels. So Niels username, email, first and last name, ID number, address. You remember the storyline? You remember the storyline? Let's go back. Let's go back. Remember this? Many targeted phishing emails containing information that is not public. I think we are starting to understand why this is happening, because apparently there is an IDOR vulnerability right here. Because if someone can just change this ID to something else, they will probably see some information that doesn't belong to them. So let's see. Let's go back. So let me scroll down. All right, where were we? Right here. Okay, user ID equals 10. We got that request. What is it next? In the image, in the above image, we can see that the user ID with the value of 10 was used for the request. If we click and expand response tab, yes, we already saw that, all that data. This tells us that the application is using our user ID as a reference for getting details. Yes. Let's see what happens if we change this in the developer tools, navigate to the storage tab and expand the local storage drop down on the left side and click the URL inside it. Okay, I can already see where this is going. So there's the user ID right there. We are going to change it to 11 and see what happens. So yeah, okay, let's do that. So let's change it to 11. So again, we have the request right here. Let's go into storage here on the right side. Then back to the left, we have local storage. Let's click on this IP, which is the IP for our app. And now here we have this value right here, user ID. Just double click on it and let's put 11. Let's click enter. Now let's refresh the page and see if anything weird happens. So I've refreshed the page. Let me close this. Now, oh my God. As you can see, we are still authenticated as Niels. So even though we haven't changed our user, we are actively using the same account, but because of this insecure direct object reference that is the user ID, now we have access to information about other user, which is the test user that has no children and apparently has a couple vouchers as well. So people could steal their vouchers if they get access to this, that's not good at all. Let me go back. This is the simplest form of IDOR. Simply changing the user ID to something else means that we can see other users' data. Exactly. Some IDORs might be slightly more hidden. Just because you don't see a direct number doesn't mean it doesn't exist. Let's dive deeper. To continue on to the next challenge of the task, go and change the ID back to 10 using the same steps you followed above. Alright, let's do that before anything else. So let me inspect it again. Go into the local storage. And now I'm going to double click onto the number and put it back to 10, right? And if I refresh it, now I should get Niels' kids back, right? Exactly. Niels' 5 kids are here. Now, in this case, obvious references. Some IDORs might not be as simple as just a number. In certain cases, encoding may have been used on the loaded profile. Click the eye icon to see the first child as shown in the image below. Alright, so let's go back to our attack box and first name is Bilbo. And I want to check here with the I button some information about Bilbo. Let me inspect this, go into the network and see what we get. So let me click on it again. The I, yes, so we got some information right here. Again, the account information user ID equals 10. And then we have this other request right here for an MG equals thing. What the heck is that all about? Let's see. So if we go back to the network tab, take a look at the request being made, you should see a request like this. Exactly. This is exactly what we got. And if you take a look here on the right, you can see that before the MG equals, we have something that is B64. B64 stands for base 64, which is a form of encoding. Now, in order for me to show you what base 64 is all about, I'm going to be using a tool called CyberChef. This is something you can just Google. It's really easy. So if you come here and you just type base 64 and you just drag and drop the 264 recipe here on the right. Now, my input, I can type whatever I want in here, but if I type 1, you will see that 1 equals to MQ equals in base 64 encoding. So if I just keep doing that, for example, 2, now I get this output right here, MG equals, which is basically what we get here on the request, right? So this just tells me that the website for the children's ID, they're using base 64 encoding in hopes to hide that specific ID. So we can't really use 2, 3, or 4, but if we use base 64, we will be able to do so. Let's see what TryHackMe says next. Simply put, the MG equals is just the base 64 encoded version number of 2. Exactly. So we could still perform IDOR using this request, but we would have to use the base 64 encoded number first. All right. So encoding is not the most secure way to fix this issue either. Now, in digest, objects remain. Encoding isn't the only thing that can be used to hide potential IDOR vulnerabilities. Sometimes the values may look like a hash, such as MD5 or SHA-1. If you want to see what that would look like, take a look at the request that happens when you click the edit icon next to a child. Okay, so if we close this and now I click on the edit icon right here on the left, now we get a different request right here. And on the right, you can see that the ID is a random sequence of numbers, but it's not really that random because this is using the MD5 hash. And I know it is kind of random. What I mean by it is that this is something that we can also use, and it's not really that secure. Why is that? Well, if I go back to CyberChef and I search for MD5 and I drag it into here, you will see that now these numbers are giving me this output. So if I have a dictionary of all of the numbers between 1 and 1,000, and if I hash those numbers with this specific hashing algorithm, I will get the hashes as well. So I can just replace the hash in the requests and I will get information about the other kids as well. So again, this is not as secure, and this is not something that you'd be using to protect passwords or anything like that, because then you can just use something like a rainbow attack to match hashes that you can then revert back to the original string, and then you would have the passwords of that user. So still, even if this is another technique that some applications might use to hide that identifier, it's still really not that secure. But yeah, while the streak may look random, exactly like I was saying, upon further investigation, you can see that it is a type of hash. If we understand what value was used to generate the hash, we can perform an either attack by simply replicating the hashing function. And using something like a hash identifier can help you quickly understand what hashing algorithm is being used. It can often tell you what data was hashed. That is actually a very good point. So if we go back to our target machine and we check this hash right here, I'm going to copy this. And if we didn't have this MD5 bit on our request, it would have been a little bit trickier to understand what sort of hash there is in here. And that's why having websites like hashes.com can be very, very helpful. So if you just paste the hash right here and you submit to identify, you will see, all right, this was an MD5 hash. So yeah, there is that. All right, moving on. The last thing that we need to cover before we go into the practical questions is this part right here. It's deterministic, obviously reproducible. Sometimes you have to dig quite deep for IDOR. Sometimes IDOR is not as clear. Sometimes IDOR stems from the actual algorithm being used. In this last case, let's take a look at our vouchers. While the values may look random, we need to investigate what algorithm was used to generate them. Their format looks like a UUID, which is basically a universal unique identifier. Let me scroll down so you can see it. With 128-bit value used to uniquely identify an object, entity, or information within a system. Yeah, so let's use a website such as UUID Decoder to try to understand what UUID format was used. Let's copy one of the vouchers from the website and let's take a look at it. All right, cool. So I think we can already see it here, but if you just want to replicate it, let me just open this website here on the right side. Okay, cool. And now we can just go into our main app. So let me just close all of this. Oh my God. And let me just copy one of these vouchers. Okay, we can use this one. And now I'm going to open the UUID decoder, copy and paste it and see what type of information we can get. So we can see that the version of the algorithm being used is version 1, which is time-based, which is interesting to say the least. But all right, let me go back to our main page here. Okay. While these look completely random, we can see that there is a structure, okay? We can see that the version 1 was used, and the issue with this version is that if we know the exact date when the code was generated, we can recover the unique identifier. Yes, so because we have a certain part of the token that is being used for specific timestamps, if we know the time, the exact time where the token was being generated, or the voucher in this case, then we can recover the identifier, which is a little bit dangerous to say the least. Let's see why. For example, suppose we knew the elves always generated vouchers between 20 and 21. In that case, we can create UIDs for that entire period, which would be 3,600, because within 1 hour between 20 and 21 we have 60 minutes and 60 seconds in a minute. So some math for you math nerds out there, which you could use in a brute force attack to aim to recover a valid voucher and get more gifts. Remember the storyline? Let's go back. I remember there was this guy called Sir Carrotbane, which has many vouchers assigned to it. Now, I think they deleted the account, right? Yes, the account has been deleted. But maybe this guy was doing some shenanigans that were related to this sort of identifiers. Maybe he was doing some brute force in there and he found a way to find valid vouchers. We don't know. Maybe he was using information from other users and just stealing the vouchers. There's a lot of possibilities here, but I like that we are kind of understanding the dangers of the vulnerability and also how that could be already being exploited by this carrot guy. So yeah. All right, I think the last part is about mitigation. How can we fix it? So we need to improve design in order to obliterate the risk. So the best way to stop this vulnerability is to make sure that the server is checking for who asks for data or a feature or access to any asset within the application every time. It's not enough to hide it or just change the ID number. The system must confirm that the logged in user is authorized to see or change that information. It's not enough to rely on tricks like base64 or hashing the IDs. Those can still be guessed or decoded, like we mentioned. And instead, keep all the real permissions checks on the server. Whenever a request comes in, check, does this user own or have permissions to view this item? Cool. Use random or hard to guess IDs for public links, but remember that random IDs alone don't make your app safe. Always test your app by trying to open another user's data and making sure it's blocked. Finally, record and monitor failed access attempts. Exactly, because these can be attempts in order to brute force or get access to something they shouldn't. They can be early signs of someone trying to exploit an IDOR. Yes. Okay, awesome. Let's just now go for the main tasks for today. And I think we're starting with one that is pretty easy. It's just to get us warmed up, right? What does IDOR stand for? Now, I'm not even attempting to write this by myself. I'm going to make a lot of typos. So let me just make life easier for myself. I'm just going to copy it, but I can tell it by heart. So it's insecure direct object reference. Let's just check. Boom, there we go. First answer, we got it. Now, what type of privilege escalation are most IDOR cases? As I told you before, IDOR cases are not exclusive to horizontal privilege escalation, but usually that's the most common scenario. So here, we are just going to type horizontal, and that's correct. Perfect. Now, exploiting the IDOR found in the view accounts parameter, what is the user ID of the parent that has 10 children? Now, there's a lot of different ways we could do this. We could use automation, we can do it manually, but I think we should do it manually, all right? So if this was a case where we would have to go through thousands of different users before we get our answer, we would have to use automation. But I think we should do it manually first, just for you to understand the logic. So we are going to repeat the same logic that we had before when we changed the user ID from 10 to 11. You remember that? So I'm going to inspect this, open our development tools. I'm going to refresh the page. And yes, so we get the request right here. I'm going to go into storage, local storage here on the left, and I'm not going to type user ID number 11 because we noticed that user ID 11 didn't have any children. It was just a test user. So I'm just going to go straight to 12 and refresh it. Does this user has any children? I'm probably going to make this smaller just to make it a little bit more readable, because right now we don't really need to read any small text. So let's see if this, okay, I'm going to maximize. Yes, this is perfect. Okay, local storage, as you can see, this user ID number 12, they don't have any children. So let me go back, edit this input once again and change it to 13. Let's refresh the page. Bunny doesn't have any children as well. So let's do it again. Number 14 now. All right, let me click on it, enter, refresh the page. This user has 2 children. Okay. So it's still not the right answer. So let me go and test the number 15. Enter, refresh the page. And let's see. And there we go. I think we got it. Yes. So this user with user ID number 15 has exactly 10 kids. So 3, 6, 9, 10. There we go. What is the username? Sir breeds a lot. Nice. Nice, TryHackMe. Nice. That was a good one. For the lols. Really good. Okay. Really cool. Sorry. Okay. So what was the user ID of the parent? Okay. So the ID is 15. I thought they were asking for the username. So let me check that. Perfect. Now I always like to click here on the hint button. So this orange light bulb here on the right, because now that we know the answer, I'm just curious to see what would be TryHackMe's approach to solve this question. So you can see here on the bottom left, using the task example, change the ID value of your token and refresh the page. work in increment steps from your user's ID. Okay, so we did exactly that, so that's nice. But again, we were lucky that the answer was actually user 15, because if it was like user 3000, we would have to do that 3000 times. That wouldn't be fun. So there are ways to automate that, and I think we will take a look into how to do that approach in just a second, because now we have 2 bonus tasks, and you don't need to do this because, as you can see here, there's no answer needed. Okay, there's nothing you need to provide on the answer. You can just click on the check button for both of them and you're good to go. But because TryHackMe know about all of you advanced hackers out there that want a little bit of a challenge, we have some extra questions for you. But I think it's still fun for everyone, especially if you're up for a challenge, to just stay here and follow up and see how to find the answer for these little bit more challenging questions. So yeah, let's start with the first one. I'm gonna make this bigger again. So bonus task, if you want to dive even deeper, use either base64 or MD5 child endpoint and try to find the ID number of the child born on the 17th of April 2019. I hope this is the right date format. I think it is. To make the iteration faster, consider using something like burp's intruder. If you want to check the answer, click the hint on the question. Okay, cool. So this is what we are going to do. Let me go back to our attack box, right? And let's fire up the tool that we are going to be using, which is Burp Suite. So just go with your mouse to the right side, it will open the toolbar, and Burp Suite is this little blue square here on the right. Burp Suite is basically a proxy that you can use to intercept your web requests from your browser before they reach the web server or the web application. So it makes things a lot easier to change a couple stuff on those requests and even to automate some stuff. So that is a very oversimplified explanation of what Burp Suite is all about. So here I'm just going to minimize the browser just to make things a little bit more readable for you. So here, yeah, just click here on next to do a temporary project and just use Burp default. This is going to load, and if you're curious about the setup, how this actually works, TryHackMe did a great job just having everything ready for you. Because if I open the browser again, and I'm going to move my head out of the way, take a look here on the, oh, sorry, that's Burp Suite wanting to be the protagonist and getting all the spotlight. Just wait a second. So if I go here and I point it to above my head, what is it? Yeah, there we go, right there. You see this little fox here on your browser. This is called Foxy Proxy. So it's basically an extension on your browser where you can use Burp as the proxy to intercept the web requests. So if I just click on Burp, things will work out of the bat. Now, if you're curious and you really want to understand how this works under the hood, just click on Options. You will see that there are a couple options here. If you click on Proxies, you will see that there is already one created for you called Burp that is using the local IP address and the port 8080. If you go back to Burp, you select Proxy on the top left, Proxy Settings here in the middle, you will see it's using the same exact IP, the local IP address, and the same exact port 8080. So that's how the traffic is being intercepted. Enough about the setup. I know TryHackMe made this very, very easy, but still people might be confused, like, how is this working? Like, how in the world are we able to intercept this thing? So that's basically the setup behind it. Let me put my face back up there. And right now, you can see here on the left, there's intercept on. So whatever I do on my browser, it will be intercepted right here. Let's test it. Let me open Firefox again, close this. And let me just, let me see if this is selected. Yeah, Burp is selected. Let me just refresh this page. There you go. You can see here on the right side, if I move my head, Burp has now been activated. You can see now on top of the browser extension, it says Burp in green. The browser is loading, but nothing is happening. It's not really getting a response from the web server. Why is that? Well, that is because the Burp Suite proxy is intercepting it. So if I just click on the intercept on button, it just turns the intercept off. And if I go into the HTTP history, you can click it right away, right there. You can see all the requests in here, which is pretty cool. So right now, everything I do on my main app, sorry, if I go back here, anything I do here, it will be logged on my Burp Suite. If you want to be even more professional, by the way, you can go here in the target blade on the top left, right click on the IP address for the web app and click add to scope. And what this will do is basically burp is going to ignore everything that is not part of your scope, which in this case is our try present me application. So let's just click yes, because it will make things a lot more cleaner and remove all of the noise from here from your history. So yeah, we know that we have to use a specific type of request, right? So we have to use either the base64 or MD5 child endpoint. So let's see if we have any requests that capture that. So for that, I need to go back to my web application and let's get some information about this kid. So for example, this kid right here, let's see what we got on our yes, we got some requests in here. So number 4 is nice because I want to use the base64 one. I don't want to use the MD5. I think the base64 is easier to understand and it's a lot more cleaner. So right now, what I will do is I'm going to use a tool within burp that is called intruder. So you can just right click on this request, send it to intruder. And here inside intruder, you will see basically the web request that we are making. Now we need to define the input to where we are going to run our payload. I know this sounds very complex, but what that means is that this MTE equals, we already know that this is a base64 number, right? So if I just copy this and I go back to CyberChef, and instead of making it to base64, because I already have the base64 encoded version, I'm going to put a new recipe called from base64. And now I'm going to copy it here. And I already know this kid's ID is number 11. It's just being encoded with base64. So what I want to do is I want to ask for the application to give me the kid that has the birth date, specifically, I think it was, yes, 17 of April of 2019. In order for me to get that answer, I need to make a lot of requests with different IDs until I get the right answer. So how are we going to do that? I made things a little bit easier for us. So I have a payload that I'm going to share with you. So basically, I have this list right here. This is basically numbers between 10 and 20, okay? And we can use this as our payload. Before we do that, we need to define this as our input field. This is the value that we are going to change every single request. The way you do that is you basically highlight it and you click on this little button on the left, add. Boom, there we go. Now, if you notice on the right side, we now have the option to configure our payload, which is exactly what we are going to do in just a second. So minimize all of it, right? Let's just minimize everything and let's open our terminal. Terminal is right here on the top left. Just click on it. It will open and I'll just type the word Pluma. Pluma is just a text editor within Linux. So it's very, very simple. You could also do this on the command line. I know, chill out. Let's try to keep it beginner friendly. And I think this is also better because it allows you to see what is happening. So I'm just going to copy my list here. Remember, this is encoded numbers. This is numbers between 10 and 20. I'm going to save this on my desktop as basically just a text file. I'm going to call it list1.txt and save. And now you can see it here on the screen on the bottom left. I'm going to just leave this here. I'm going back to burp. And right now here on the right side for the payload configuration, I can load my payload. Basically, I'm going to click there on the load option, going to the desktop, select my list one, which is the text file that we just created. And now we're ready to run the attack. So let's just do that. We're just going to click on this orange button that says start attack. Boom. Let's see how it goes. Just clicking here, okay? The thing got minimized. Don't worry. Just go back to it, to the intruder window. Okay, so we have a lot of information here. So everything returned with a status code of 200, which is good. This code means that the web server actually responded with the information that we were asking for. And we have access to it and everything is all right. Even though we are trying to access information that we should have access to, but still, it means that the request worked. And now, if I just pull this little window here from the bottom, we can see the specific web request. The first thing that we requested was the MTE, which was the original request. And now, let's just navigate through all of the options, through all of the requests we did, trying to find the birth date that we are trying to get. So for that, we need to click on the response because this is where you will see the field for the birth rate here on the bottom. So the first one obviously is not the right one. So let's just keep navigating. So I'm going to go, so 1, 2, I'm just clicking on the down arrow to see if we can find it. I know it's 17 of April 2019 and there we go. So number 10, this guy, first name Willow, is the guy that has the birth date that we were looking for. And we can see that the child ID is number 19. If we go back to the request, child ID is this base64 encoded string, but here it just comes decoded with the basic 19. So if we go back to our main page and we check for the answer for this here on the orange light bulb, we can see that the right answer is 19. So we got it right. Perfect. So I'm just going to click check on that. Now for the last one, please bear with me for a second, because this one is not as easy as the previous one, because it requires you to do some math and to understand how the tokens are built and to really understand this part right here. So you remember this text we read? Yes. This is important for the last question, but let's just read through it and take a look. So bonus task, want to go even further? Using the parents vouchers claim endpoint, find a voucher that is valid on, take a look at this, pay attention, specifically on November 20th, 2025. And we also have insider information that tells us that the voucher was generated exactly on the minute, so every single minute between 20 and 24 UTC that day. So that every single minute there is a possibility that the voucher was generated. So between 8 p.m. and midnight, or 20 and 24, that's 4 hours, right? And because we know that the voucher was generated exactly on the minute, well, every hour has 60 minutes. And if we are talking about a 4 hours gap between these two timestamps, well, 4 times 60, that's 240. So we have 240 options to make this voucher. And now, how do we do that? I made things easier for you. This is a very, very good example of how you can leverage AI to help you as well to generate all of these possibilities, because as we saw previously, the fact that we are using this version 1 of UUID means that even though this token or this voucher looks kind of random, if we know exactly the timestamp or the possibilities for the timestamp of the voucher, we can generate a bunch of different vouchers and then test to see if any of those is valid. So because we have that, you can query AI and ask for a voucher, and you can even give an example of the vouchers that we have on our main app. So one of the vouchers that we have here, and then say, hey, I know there's one valid voucher that was created between 20 and 24 of this specific day, and I need to test which one of those was valid. And the voucher was generated exactly on a specific minute. So we already did the math there. There's 240 options, and I already have the list ready for you guys. So I have the list right here. So if I just scroll down and I copy this, this was the list of potential vouchers that I generated. Right now, what we need to do is we first need to go back to the endpoint that TryHackMe is asking us to use. So let me just copy this right here. Boom. Let me navigate to it. So here. There we go. All right. We're in the right spot. So now we need to go here and claim voucher. Let's just click here on this claim voucher. And here you can enter anything you want. Okay. Let's just put test. I'm even going to make it caps lock just to make it a little bit more visible when we get it on burp. And we can see that we get a result voucher not found. So if I go back to burp and let me close this intruder window, we don't really need it anymore. You can discard it. And we go back to our proxy and we go into this last request we made. It's a post request, not a get request, because now we are sending input to the web server. We are not just asking for information. So now you will see that here on the bottom, the voucher that I tried to redeem was test. And what was the response here on the right? Voucher not found, error 404. So now we are going to use the same request. Again, this is the same exact logic from the previous question we got. So let's just send this request to intruder, navigate to intruder. And now, like we did before with the kid user ID, we are going to use the input for the vouchers. So this test string that I included, I'm going to select it as my input field, and you just do that by, again, selecting it and clicking on this add button on the left. And now on the right side, you already have the options to submit your payload, which is what we are going to do. So let me go back to my list. copy it. This is the list that I have generated. We go back to the attack machine, minimize everything. Remember the Pluma text editor? You can just double click here on this bar or file and new. I'm just going to double click here. You paste all of the possible vouchers and you can see there's 240. I'm going to save this as list2.txt and save it on the desktop as well, just because it's easier. Now everything is right here. You can see list 1 and list 2 here at the bottom of my screen. Can minimize it, and now go back to Warp, load that payload that we got, open it, and now let's start the attack. Now this is probably going to take a little bit longer because again, we're not just testing 10 or 20 different possibilities. We are testing, as you can see here on the right, payload count 240 different possibilities. So I'm just going to run the attack. Click OK, and again, because most of these vouchers will be invalid or not legit, you will get 404 not found status codes. What we are looking for is a status code of 200, which means that we were successful and that voucher is actually valid. So let's see if we can find it. This is still running though. It's 240 possibilities, so it's still, you can see here on the bottom left, 36, 37, it's still going. Let's see if we are lucky and it's one of the first ones. Not yet. Let's see, still scrolling down. Oh, there we go. There we go. Let me color code it with red. Double click on it and make it red so it's more visible. And right now, okay, let me pull up this window here from the bottom. Because I know this had a 200 status code. I know it was successful, so I already know this is the one. Maybe there's a couple more. I don't know. The question was just talking about one voucher. So maybe there's a couple more in there, but I'm just going to go with this one for now. So there is this request that we did. We provided this voucher. If we go here to the red, it's the one that is right here on the payload. And let me check the response. Boom. It's okay, as you can see here on the top. So this was the voucher that actually was legit. So I can see that it starts with 22643E00 C655, and I think all of the rest is basically the same for all of the payloads, if I can check it right here. Exactly, so the later part is basically the same, but this part in the beginning, these first two set of characters are the ones that are variable. So if this matches our right answer, we got it. So let me just check it. Bonus question, let me check here on the hint on the right side. Answer 22643E00C655, and yes, we got it. Awesome. So let's just check it. If you enjoyed today's room, check our complete idle room. Make sure you do that because as you could see, this is a lot of fun. And I'm just going to check that and we're done. Yay! And that was it for today. I really hope you enjoyed this walkthrough. Let me know what you think and I'll see you in the next one. Bye!